Hello friends, welcome to my YouTube channel Make Maharashtra, which gives you more educational videos. Now see here, as I told you, the belt manufacturing process, that is flat belt, from selection for flat belt from manufacturing catalog, the three conditions as I told you, this first one kW max, then arc of contact through that kW corrected and corrected power rating, and divide this, will get width into number of ply and calculated length. These are the only four formulas we need to use. So we'll go for solving the numerical. Just I'll read the numerical, just listen, understand first, and then try to solve. See, it is required to select a flat belt drive, open belt drive, of course, for a compressor, very important, compressor running at 720 rpm, correct? Compressor running at 720 rpm, which driven by 25 kilowatt at 1440 rpm. This is the motor rpm, smaller pulley, and bigger pulley rpm 720. The space available for a center distance 3 meter. This is center distance. Belt is open type, they have suggested. Clear? I have drawn the diagram, this, and showing the center distance, diameter, rpm. Okay, both are in same direction. Now first step, very simple, as we must find out the velocity first, because we just find out this C, kW max is equal to FA into kW. So this formula I will have to fulfill. How? Check. First of all, I will calculate velocity. Velocity is equal to, now pi dn by 60 into 10 raised to 3. In case of smaller pulley diameter, we don't know. So I'll calculate d is equal to v into 60 into this. So 60 into rpm they have given, velocity is 18. I told you we need to assume velocity in between 17.5 to 22. So I have assumed here 18 meter per second. So by putting this 18 meter per second, I'll get the diameter of 238. So what it indicate? Just listen. Just listen. What it indicate? When the velocity is 18 meter per second, it will gives you the value of 238. 238. Clear? Now 238 pulley diameter is not possible. Not possible to generate. So that's why we'll have to take a round figure 250 mm value. So if I take the diameter 250, of course that velocity from 18 to something changes. So correct. So for that velocity 250 diameter, I need to calculate velocity. See, again I use this equation. I put the value of diameter 250. I will get 18.85 meter per second velocity. So this velocity I need to take for further calculations. Understood? I'll repeat the step. See what we did. We must know the diameter. Right now we don't have diameter, correct? So to calculate that diameter, what we'll have to do? So velocity equation we know, v is equal to pi dn by 60. We need to assume the velocity as per the assumptions. So we have assumed 18 meter per second velocity. For 18 meter per second velocity, the diameter is 238, which is not possible to maintain. We have to take a round figure, na? So that round figure value I took 250 mm. Now if I take the 250 mm, again I use same equation and I put the value of d, small d, 250, and calculate the velocity, and that velocity is 18.85 meter per second, and this we are going to carry for further calculation. Clear? Now we have decided smaller diameter is 250. Of course bigger one is, we need to assume 2 times of smaller, this is 500. So this is 500 mm and this is 250 mm, correct? So these are the dimensions with respect to velocity we have calculated. That will be our first step. Next what happened? We know maximum power. So this equation we have written, kW max is equal to FA into kW, correct? This equation, understood? So I'll show you this, don't confuse. So this equation. So for that, see, maximum power we don't know, V is equal to, now in example they have mentioned compressor. Are you getting it? Compressor. So I will have to select compressor for selecting this FA value. So I will go through the chart. See, This is FA chart, application correction factor. Now normal load, no compressor is mentioned. Centrifugal, no compression is mentioned. Here blowers, compressor, reciprocating pumps and all that. So compressor is here. So I will have to select value of FA 1.3. So that's why 1.3 into maximum power they have given 25 kilowatt. So 25 kilowatt. So just put the value, I will get the maximum power kW max is equal to 32.5 kilowatt. First step is over. Understood? Next, arc of contact factor we have seen. Arc of contact, this chart. Clear? Arc of contact factor. So we have to calculate what will be the angle. This is in degree, all the angles. So what will be our angle for this application? Now we know this is open belt drive. I can use equation alpha is equal to 180 minus 2 alpha. So 2 alpha is nothing but sine square, sine inverse of d minus d divided by 2c. So d is known, small d also known, center distance we know. So from that I will get alpha 175 degree. Clear? From that I will get 175 degree. So I will have to select value of arc of contact. See 175, this is in degree. So 175 is situated in between this 170 and 180, and the value is 1.04 and 1, correct? So our arc of contact factor is situated in between this. So for that I will do the interpolation like this. See here, FD is equal to 1 plus 0.4, 0.4 remains na, into see here, understand carefully, into 180 minus answer divided by max minus minimum. Understood? See from the chart, it is situated in between 170 to 180. So I will take 1 plus 0.4 into 180 minus 175 divided by 180 minus 170 by this 2. So that gives you the value of arc of contact, and arc of contact is C. 1 plus 0.04 remain into 180 minus answer divided by max minus minimum. So it will gives you 1.09 value of arc of contact. Now we know the equation corrected power. This corrected power is equal to kW max into FD. So kW max we have calculated. So here corrected power is equal to 1.0 FD and kW max this 32.5 we have calculated. So by putting this multiplying we will get 33.12 kilowatt. This is the corrected power. Okay. Now whether which type of belt they are using, is there any indication they have given? No. Either high speed or 4? No. So we can take assume high speed. So we have to write for high speed belt. Now for high speed belt what we have seen, for high speed belt we will have to take corrected power rating. Now corrected power we have calculated. Now corrected power rating is 0.0118 into velocity divided by 5.08. So same I will perform here. For high speed 0.0118 into velocity, that is 18.85 into divided by 5.08. So we will get the corrected power rating 0.0438. And last will be width into number of ply is equal to corrected power 33.12 divided by this power rating. So it will gives you width into number of ply. Correct? So number of ply is equal to, I will have to divide the width. Correct? Or if I want to calculate width, I will have to divide number of ply. So basically we need to calculate width because number of plies chart are given. This chart. See, this will be the chart. Now how to find the width? Check it out. See, our answer is 756. So width is equal to ply. I will divide ply. So first ply I took 4, 756 by 4, 189. So I will go to 4 ply system, 4 ply. 189 is there? No. So this I cannot use. Then I go for 5th ply divided by 5. It will gives you 151.23. 5 ply it will gives you 151, so which is nearer to 152. So I can select 5 ply. So therefore my system is suitable for 152 mm, preferred for 5 plies as per the for this given statement. Okay, and then last will be, this is a flat belt drive, open belt drive. L is equal to same equation we need to use, and through which we'll get the length, it is in mm. Clear? So likewise we have find out the design of flat belt drive on the basis of manufacturing catalog. I hope you understood. I'll again repeat the things. Very simple. We have calculate first the diameter. That diameter will make the round figure, and through that diameter we have calculate final corrected velocity. We know the equation of kilowatt maximum is equal to FA, application factor or load correction factor, into power. So 1.3 I have select for this compressor from the chart. So I'll get 32.5 for maximum power. Now my role is to find out the corrected power rating. This, for this I need to calculate, corrected power rating, this. So how I can calculate? FD, arc of contact factor, 180 minus 2 pi. So I'll put the value, I'll get 175. I'll select the chart. It is, this value is situated in between 170 to 80 here. So I'll take the interpolation here. I told you how to take, and through which interpolation we can select the value, that is 1.019. So I'll directly multiply this. I'll get the corrected power rating 33.212. Now its next step will be to calculate high speed corrected belt rating. So if I consider the high speed belt, so corrected belt rating is, equation is given in the chart, 0.0118 into velocity divided by 5.08. So through which I'll get this much amount of corrected belt rating. I divide this by this, corrected power divided by corrected belt rating is equal to 756. Next equation I know, that is width into ply is equal to this. So I know the chart of the number of ply, so therefore I'll get width. So number of ply, after dividing this, after 4, this value is not situated in the chart, so this I skip, I went to 5th ply. So this value is nearer to 152, so that's why my selected value is 152 mm width for 5 ply system. And last step is to calculate length of belt drive. So direct equation, and we'll get 7183 mq, or we can say 7.2 meter with 152 mm width and 5 ply system will get. Okay, please revise it, do from your side, practice it. Okay, thank you.